Okay.
You ready? All right. I'm going to teach you guys today about the pancreas, the hormones that it secretes, which is insulin and glycogen, and the diseases that it causes if you don't have enough of either of those, which is diabetes type 1 and type 2. So the pancreas is a flat organ, which is behind the stomach, posterior to the stomach, yeah, that's behind, and behind the parietal peritoneum. Guys, this is my first day teaching, so I'm still a very nervous teacher. The pancreatic duct joins the pancreas to the duodenum and transports digestive juices to the small intestine. Are we good?
I think so, yeah.
Okay. There's two major ducts that secrete in the pancreas. So they have a dual function. There's an exocrine gland, which secretes the digestive juices, and there's an endocrine gland, which releases the hormones. Endocrine portion of the pancreas is closely associated with the blood vessels. There's groups of cells which form islands or islets. This is really bad.
Continue, you're doing fine.
There's two types of cells in these islands. The alpha cells, which secrete glucagon, and the beta cells, which produce insulin. And insulin lowers the blood glucose by increasing the rate of glucose uptake and utilization by most body cells. So the hormones, like I mentioned before, that the pancreas secretes is, the first one is glucagon, and it stimulates the liver to break down glycogen and certain non-carbohydrates such as amino acids into glucose, and also raising the blood sugar concentration. Glucagon is much more effective by elevating the blood glucose than epinephrine. So insulin, which is the major one, everyone's heard of insulin, and which happens if you don't need it or if you don't make enough of it. It stimulates the liver to form glucagon from glucose, but it also blocks the conversion of non-carbohydrates into glucose. Insulin has a special effect of promoting facilitated diffusion of glucose, or I always think of glucose as sugar, it's easier for me to remember that, across the cell membranes and that have the insulin receptors. The action of insulin decreases the blood sugar concentration, and insulin secreted promotes transportation of amino acids into cells, increasing protein synthesis, and stimulates the adipose cells to synthesize and store fat. I do have some diagrams that I'll show you guys in a minute, which breaks it down a little bit easier, and it's easier to understand than all this technical words. So what controls the pancreas? The pancreas secretes its digestive enzymes through a system of ducts into the digestive tract, while it secretes its variety of hormones right into the bloodstream. So there's two different things there. Abnormal pancreatic function can lead to either pancreatitis or diabetes. So diabetes mellitus, is that how you say it?
Mellitus, yeah.
Is a metabolic derangement that arises from lack of insulin or ability of cells to recognize the lack of insulin. Insulin deficiency of diabetes disturbs carbohydrate, protein, and fat metabolism. Since insulin helps sugar or glucose across cell membranes, movement of glucose into adipose and resting skeletal muscles decrease, and at the same time formulation of glycogen declines. So then you get type 1 or type 2 diabetes. Type 1 diabetes is usually diagnosed before you're 20. It's also considered the insulin-dependent diabetes. So they've also referred to it as juvenile because you get it before you're 20. It's an autoimmune disease, which means the immune system destroys the beta cells of the pancreas. Treatment for diabetes type 1 is insulin injections, and they can be given several times a day, or you can have an insulin pump put into you, so it just does it on that. Type 2 diabetes is the non-insulin dependent, or the one that you get when you're older. Usually diagnosed past the age of 40, but it has milder symptoms than type 1 does. 85 to 90% of people with diabetes have diabetes type 2. Basically, the beta cells produce the insulin, but the body cells lose the ability to recognize it. The most effective people, or most affected people, are obese, overweight, and like I said again too with age. Treatment includes controlling diet, getting out and doing some exercise, and get your body down to a desirable body weight. But oral, people don't take insulin for type 2, like dependent, but they can control it with oral drugs, the glucose levels. Excuse me. This I know, my cousin was diagnosed at the age of 41 with diabetes type 2, and she was overweight. She was over the age of 40 and obese, I guess you would say. And she didn't want to be on drugs for it, so she did do the exercise and the diet and taking the sugar out of her diet. Not completely, but most of it. And yeah, she lost like 82 pounds or something like that and changed her whole body type. And the doctor had said too that if most people would do what she did, they'd have a lot fewer people with those types of symptoms. So, some handouts for you. How does your body use the insulin and glucose that's in your body? So with normal functioning, the insulin is the key to letting the glucose enter the cell, and glucose in the cell is transformed into energy in the body. So as you can see, it's all working together there. My pointer. Sorry. Type 1 diabetes, which is right here. The pancreas is not producing the insulin, and the glucose is not able to enter the cell, as you can see there. And type 2, the pancreas still produces insulin, but not enough, and it's inadequate amounts of glucose or sugar in the cells. So you can see it's in some of them, but it's not enough to make it work in your body. So here's the diagram of type 1 diabetes. The stomach, right here, changes food into glucose, and then the glucose enters the bloodstream. The pancreas makes insulin or very little amount of insulin, so little or no insulin enters the bloodstream, and then the glucose builds up in the bloodstream. So that's type 1 diabetes. In type 2, again, the stomach changes food into glucose, and glucose enters the bloodstream, over here. But the pancreas makes the insulin, and the insulin enters the bloodstream, but it cannot get into the cells, and then again, glucose builds up in the bloodstream. That's about all I have to say about that.
Good job. Any questions for Sandra?